Okay, we are doing 13.4 and 13.5. We're just continuing what we already learned from yesterday. Okay, so remember, like terms and terms that have exactly the same variable factors, so means same variable and the same exponent. So we need to know this for today. You need to know that these are examples of like terms. You're looking at the variable, you're looking at the exponent, the variable and the exponent. So those are examples of like terms. Unlike terms would be like 2x and 4x squared. So even though they have the same x term, one squared, one is not, they're not like terms, therefore you cannot combine them or put them together. So that's the idea. I can put these together, I cannot put these together. Okay? All right, so to add polynomials, you're going to group your like terms together, which basically just means you're adding your coefficients and you put them in standard form. So you have 3 examples here of different types of problems. Now I just want to clarify, because do you notice that on 4 and 5 there's parentheses, and then on number 6 there's no parentheses? The only reason it's just some books do it differently. They're not really different problems. This one's just saying this trinomial plus this trinomial. This is just putting it all out there. You're going to do the same thing with both problems. It just initially looks a little different. Okay, so when I look at number 4, I am going to start with my highest exponent, because then I can automatically put it in standard form. So I look at number 4 and I go, okay, what are my like terms in this trinomial and this trinomial? What would those like terms be, Nick?
5x squared and 2x squared.
Okay, so I'm going to put 5x squared and 2x squared together. When I do that, what do I get? So you just add the coefficient. What's coefficient, by the way? What does that word mean when I say coefficient? What is that, Josh?
Like power.
Not the power, it's the what?
The base, like the big number in front of it.
Okay, so it's the number in front of the variable. Okay, so when I say add the coefficients, I'm just saying add the 5 and the 2 and I get what?
7.
So this becomes 7x squared. Then I'm going to go to my next highest exponent. What would I put together next? What are my next 2 like terms that I can put together? Quinn, what do you think?
Negative 3x and 5x.
And what is negative 3x and 5x together? Well, negative 3x plus 5x. The 2's right. Is it going to be positive or negative?
Positive.
Okay, so positive. So positive 2x. So that was this term and this term put together. Constant terms I can always put together. I've always been able to put numbers together. In this case, 7 minus 7, that just cancels each other out, right? So you're done. I've combined all like terms. It's in standard form. So remember, you look at your exponent. That's it. Okay? Look at number 5. On number 5, I have 3x squared plus 9x plus 3 plus the binomial 6x plus 9. So where would I start? What am I going to do, Charlie? What do you think?
Combine 9x and 6x.
I'm going to do that. I agree with you, but am I going to do that first?
No.
So, Charlie, what could I drop down first?
I don't know.
Help them out. What am I going to drop down? What am I dropping down? So I can't combine it with anything, but it should go first. What is it, Nick?
3x squared.
Okay, so Charlie, you with me that you see that 3x squared? I can't combine it with anything, but think about standard form. Wouldn't that go first? Because that exponent's highest. So I'm going to go ahead and drop it down. Then, Charlie, I agree with you. 9x and 6x, what do I get? Anybody, tell me.
15x.
Okay, so it's positive 15x. And then my constant terms, my 9 and my 3, I get what?
12.
So positive or 12 or a plus 12. Have I combined all my like terms?
Oh.
Yes, I have. Is it in standard form? You're done. Okay? This one's a little bit longer, but again, you're just going to go through and find your like terms and put them together. Okay? So, Nick, where am I going to start? Nick Tab, what am I going to do? What is my highest exponent on this one?
5.
Okay, so I'm going to look through and I'm going to find all of my terms to the 5th power. So I have 5x to the 5th power and another 5x to the 5th power. So when I put those together, Nick Tab, what do I get?
I don't know.
Add your coefficients. Add the numbers out in front.
10x.
Okay, so you get 10x to the 5th power. Okay? Then I am going to go to my next highest exponent. So what's my next highest exponent, Brandon?
9.
Hang on, exponent.
Oh,
Exponent. Okay, so it's the 3x to the 2nd power. Can I combine that with anything? No, so I'm just going to drop it down, plus 3x to the 2nd power. Then I have, hang on, I couldn't see that. Then I have a positive 9x and a negative 9x. What do we think is going to happen with that? What's going to happen there? Jacob, tell me. They're just going to cancel out. So this and this are just gone. And then I have plus 3 and another plus 3. What happens with those?
Add them together.
And I get,
6.
okay, I look through it. I make sure that I've combined all my like terms, and I have. And I make sure it's in descending order or standard form. Means the same thing. Okay, look good? Okay, so do you know how to add polynomials now? Yes. Okay, now let's go to subtraction. Subtraction's very similar. There's just one extra step that goes along with it. Okay, so when I am subtracting, to subtract polynomials, you must change each of the terms after the subtraction sign to the opposite. Really what you're doing is you're distributing a negative 1. Okay, does that make sense? You see that? Okay, so what happens is I'm just going to rewrite my problem. So this first trinomial does not change. I'm just going to drop it down. This second trinomial, however, I'm subtracting it, which all I'm going to do is distribute that negative 1. When I distribute that negative 1, all it does is change each of these signs, because negative 1 times 3 is negative 3x cubed. What's negative 1 times 2x? Negative 2x. What's negative 1 times negative 2?
2.
So a positive 2. So do you notice that all it did was flip those signs? That's all multiplying by a negative 1 does. Okay, now this looks like a problem like number 6. Okay, so there's that extra step with the subtraction. You just have to distribute that negative. Now I'm going to combine like terms. Where am I going to start, Maddie? What am I going to put together first?
2x and 3x.
Okay, so the 2x cubed and the negative 3x cubed. Okay, so there's, these two are like terms. So what is 2x cubed minus 3x cubed, Maddie?
Negative 1.
Sure. So negative 1x cubed. Okay. Now what's the next thing that I am going to put here, Bailey?
Drop down the 4x squared.
Okay, so plus 4x squared. Okay. Then what's going to come next after that? Jonathan, what's going to come next? Are you doing this with us? Oh. Josh, what are you doing? Okay, so minus the 2x. And then lastly, what am I going to do? What's the last thing that I'm going to do, Wes?
Add the 2 and the negative 6.
Okay, so 2 and negative 6 gives me what?
Negative 4.
Okay, so or minus 4. I look through, I make sure that I don't have any like terms anymore. I don't. And I also make sure it's in descending order, and it is. Okay? You do number 8. See if you get that correct. You do it, I'll do it. We'll see if we get the same thing. Okay, so remember this. You're distributing that negative 1 before you do anything else. Do I change this first binomial? No. see if you got the same thing. Yes, making sense?
Yeah.
Okay, tomorrow when you come in, you'll have a worksheet to do. We'll do it together in class. And the idea is you go home tomorrow, weekend, no math homework. Okay? Questions?